In 1928, on this day, Alexander Fleming first discovered penicillin. At the time, Fleming was studying influenza. He had cultures of Staphylococcus, which had grown mold. He noticed that in the areas surrounding the mold, no bacteria had grown. Further experimentation was needed to isolate the substance that this fungus had produced. At first, Fleming's lab assistants found this substance to be too unstable. Alexander Fleming coined the word penicillin, but the substance was developed into a drug by Howard Florey and Ernst Chain.
Penicillin began being mass-produced by the 1940s. Since then, we've become accustomed to taking antibiotics whenever we suffer from bacterial infections, and death by infections become very rare in the developing world. It's something we've become so accustomed to that overuse has put us at risk of reverting to the pre-antibiotic era. Reckless prescribing, unfinished doses, and the use of antibiotics in the meat and dairy industry have caused bacteria to start becoming resistant to available antibiotics, among other reasons, of course. This problem is not helped by the lack of new antibiotics in production.
One example of a resistant bacteria is MRSA, standing for methicillin-resistant Staphylococcus aureus, which has already caused many deaths in the elderly, immunocompromised, and patients undergoing invasive surgeries. Bacteria already possess intrinsic resistance, but they have also been found to develop resistance mechanisms. Antibiotics often target a specific sequence. If bacteria undergo mutations of their antibiotic target, the drug is no longer effective. The bacteria can hide. Not only do bacteria replicate at a high rate, passing on their mutations, mutations can also be passed via horizontal gene transfer. Natural selection does the rest to form a fully resistant colony. Some bacteria can directly modify and deactivate antibiotics upon exposure, whilst others simply remove antibiotics from the system via efflux pumps. Overexpression of efflux pump genes is a main player in resistance.
Novel technologies such as CRISPR-Cas9 and bacteriophages have been tested as candidates which directly edit the bacterial genome for increased antibiotic sensitivity. The production of sequence-specific drugs has also been considered. Many ethical issues prevent fully trialling these methods, as bacteria would need to be modified within the infected human. Although promising, the emergence of new techniques doesn't mean an end to the fight against resistance, so for the time being, strict regulation and carefully considered use remains our only option.
So until then, remember to always finish a course of antibiotics. Consider a reduction in your consumption of animal products, or even just a swap to organic meat and milk.